Hello, good morning, good afternoon, good evening, depending on where you're joining us from today. And welcome to this Oasys XDisp webinar. My name is Norbert Kovac, and I'm one of the business development managers here at Oasys. There are quite a few names which I already recognize and some which I don't. So just for the benefit of anyone who's new to Oasys, Oasys stands for ARUP Systems. We're ARUP's in-house software developer, and we provide digital solutions for geotechnical structure engineering, as well as pedestrian simulation. Being part of ARUP is a great benefit because as an independent company means that we can focus solely on the development of leading engineering solutions. And now with that, let's talk about today's topic. So today we're going to be talking about, the topic is beneath the surface, versatile techniques for ground movement assessment. As I mentioned before, we're going to focus on XDisp today. However, our presenters are going to also mention some of our other software which they have used in their workflow, and with some focus on the more advanced features of XDisp, which is part of the XDisp Pro package. And with that, let's have a look at the housekeeping. So we are going to have a Q&A session. We should have plenty of time for that. So make sure that you ask all the questions that you have. The Q&A should be towards the top middle part of your screen. So if you just click on that, you should be able to post your questions. Sometimes it does happen that it's not there. So no worries. If it's not there, just put your questions into the chat, and one of my colleagues is going to transfer it over into the Q&A section. The webinar is going to be recorded, so no worries if you know anyone who couldn't make it today, or after seeing the webinar you thought this might be useful for one of your colleagues or anyone else, feel free to share it. This is going to be uploaded about 48 hours after the recording. It's going to be on our website as well as on YouTube. And then finally, give us a follow on LinkedIn. We have a great team always putting material out there, information about webinars, developments, case studies. So it's a really good and easy way of keeping up to date with what's happening. Quite a few of you have already connected with me on LinkedIn. I also post these, so that's also another way of doing it. Now, today's presenters. So we're going to have 4 presenters. We have Cecília Pereira. She's our geotechnical application specialist here at Oasys. And we're joined by our colleagues from ARUP. So we have Sam Taylor, geotechnical engineer, Geraldine Chung, and Aidan Hopkins, both senior geotechnical engineers. Now, what are they going to be talking about? We will start off with an introduction to Oasys XDisp. So this is going to be for the benefit of anyone who hasn't heard about XDisp before, just a brief and basic introduction, followed by our colleagues from ARUP. So the first case study is going to be presented by Sam on multi-storey building redevelopment, including deepening of the basement, followed by Geraldine on the topic of high-speed to infrastructure and construction. And then finally, Aidan is going to wrap up on large models. And then, as I mentioned, we're going to have the Q&A. And with that, I am going to hand over to Cecília to start off with the introduction to Oasys XDisp. Cecília, over to you.
Welcome, everyone. And thanks, Norbert. Thank you to everyone for joining us today. Oasys offers a powerful suite of geotechnical software designed to help engineers efficiently analyze and solve complex ground engineering challenges. Our suite includes ALP and PILE for pile analysis, Greta for retaining wall design, FRU for flexible retaining walls which support deep excavations, SLOPE for slope stability analysis, PDisp for displacements due to pressure, and of course, XDisp and XDisp Pro, which are specialized tools for assessing ground movements and their impact on adjacent structures. Gopher and Giraffe are our latest additions to the suite and are both cloud-based software. Gopher is our 2D FE analysis program, and Giraffe is our graphing tool, which works with open ground. In this session, we will focus on XDisp, which plays a critical role in projects involving tunneling, deep excavations, and infrastructure development in urban settings. So let's get started with our introduction to the Oasys program XDisp, which calculates 3D displacements in soil due to excavations. I am Sisra, as Norbert said, the application specialist for the Oasys geotechnical suite of software. So Oasys XDisp calculates the ground movements induced by tunneling, embedded wall excavations, or mining works. This will be in terms of three-dimensional displacements and horizontal strains. It can perform subsequent building, utility, and rail damage assessments using the calculated ground movements. Multiple construction stages may be specified. In XDisp, tunnels are specified as cylindrical excavations in soil. The equations used are based on the normal probability or the Gaussian distribution theory. Based on user input parameters, XDisp will generate settlement profile at the surface or at a specified depth. For embedded wall excavations, these are described in plan as polygons with a level at each corner or as circles with a single base level. Each wall of a polygonal excavation and each circular excavation is assigned horizontal and vertical ground movement curves that are then used to calculate soil displacements. Settlements and horizontal ground displacements can also be calculated. Graphical and tabular outputs are available. Mines in XDisp are specified as excavations of rectangular cross-section in rock. The method of ground movement calculation is based on the theory described by Wren et al. So the typical use of XDisp would be in tunnel excavations, shafts, retained cuts, for example, deep basements, or in mined excavations. In XDisp, we categorize damage assessment into three key types, each designed to provide valuable insights into different aspects of structural impact. These are building, utility, and rail damage assessments. XDisp assesses building damage using the well-established Berland method. The assessment categorizes damage based on tensile strain thresholds, helping to determine the severity of the impact. In utility damage assessment, XDisp performs it by calculating pull-out, rotation, axial strain, and flexural strain at different points along their length. It then checks whether these values meet the specified acceptance criteria, ensuring a clear evaluation of potential impacts. In XDisp, rail damage assessment, on the other hand, is carried out by calculating cant and twist based on ground movements determined by the software. These results can then be compared to against specified acceptance criteria to assess whether they fall within the allowable limits. We will now look at some useful features of XDisp Pro, which is our powered-up version of the standard XDisp. XDisp Pro allows modeling of stages in construction. This would be in terms of inclusion or exclusion of tunnels in particular stages, varying embedded retaining wall or excavation depth in different stages, or varying tunnel diameters in different stages, in order to represent, say, for example, pilot tunnels advancing ahead of main tunnels. In the image that I have put up here, you can see that there are 9 stages specified, and with XDisp Pro, you can look at the ground movements as well as how each of these stages affect the buildings and utilities nearby. You can then identify which stage is causing any critical limit failures and make necessary changes. Now let us have a look at some extra helpful features that we have in XDisp. Batch export. Once the analysis is complete and the results are available, there will be a number of charts and graphs that are available. So with our option in the program menu, you can export all the charts together as a bulk export. The export process allows you to select chart categories, choose a file format, and define the save location for the exported files. Interoperability with Oasys software. XDisp can be easily used in conjunction with other Oasys programs. For example, XDisp cannot deal with loads, so if you want to look at the effect of loading near an excavation, then you can analyze the loads in PDisp, import the displacement to XDisp, and then have a look at the combined effect. As with all our Oasys programs, an application programming interface or API is provided by COM Automation in XDisp Pro. COM Automation allows commands to be issued from a separate process via a set of Python, VBA, or C++ instructions. These separate process could be Python script or VBA script called from a spreadsheet or a separate program. We do have some examples which are shipped with the program, so you can use them as a base and build up your scripts quite easily. And with that rather short introduction, I now hand over to our ARUP engineers to discuss how they have used XDisp in real-life projects. Thanks everyone for listening.
Okay. Right. Hello, everyone. I'm Sam Taylor. I'm a geotechnical engineer at ARUP. Been at ARUP for 4 years, and I've primarily been working on large basements in London, and more recently doing a bit of rail geotechnical engineering asset design. So the first case study I'm going to be talking about today is a redevelopment of a multi-storey building, multi-use building, which includes a deepening of the existing basement. We have some pretty sensitive assets nearby, which is a grade 2 listed building, also just general buildings round, not listed, but still needs to be assessed, and also some sensitive sewer assets. So for the stage 3 design and stage 4 design, REBA stage 3 and 4, we had to do a ground movement assessment for both buildings and utilities. So we used XDisp Pro. You can see on the top left, it's a ISO showing the excavation in the middle of our basement, and then the building lines which you define in XDisp, as well as you can see it a bit clearer on the bottom right in the plan view. It's polylines representing the utilities, and then in the middle we have an elevation just showing where our superstructure is and the different levels at which you can set your buildings at, depending on where you feel they need to be defined, whether at ground level or at a specific foundation level. So the workflow from how we wanted to do this was actually we used Through and PDisp, which Sarah briefly mentioned in her slides. So we use ground movements. So we created ground movement curves from the deflection profiles from Through. We used Python script to then input that into XDisp. We then also used PDisp to generate ground movements due to building unloading and loading. So these all went into XDisp, and then we used the results to write our buildings assessment report and building impact assessment report and utilities. And within that, we use the batch export feature to streamline creating our appendices. So what was really crucial in this project was actually the staging, because we wanted to see the cumulative effect of the demolition, the pile installation, the excavation, and then the building loads long term and short term and long term. And this enabled us to get a full picture of what was happening at each stage. But then also what was really good was that we were able to create additional stages which were incremental. It allowed us to quickly see which stage was kind of governing the movements, and especially it was very useful for deciding our movement alert levels or trigger levels for the monitoring during the construction. And yeah, as you can see, there's a lot of lines, a lot of stages. So the batch export was really useful for this. So yeah, 15 stages total where we wanted to look at the cumulative impacts as well as the incremental impacts and how the data of the ground movement curves from through were impacting the movements. So we had a separate incremental set stages for the through and then another set of incremental stages for the PDisp. So we could really build up a picture of what each stage, what was happening at each stage, what was happening for each of the building assets, and what was happening for all the utility assets. So there's a lot of data, and the batch export really helped the streamlining of that. And so on that very standard XDisp example, I'm going to pass on to Geraldine for the next case study. Thank you.
Hi everybody, thanks Sam as well. So my name is Geraldine Chow. I'm a senior geotechnical engineer based in London. I've been involved in a lot of urban development projects in London and various different places as well. And in addition, my more recent sort of involvement was on the HS2 development. So what I'm going to talk about here is something is already published, where there is a paper that has been written by my colleagues who has been developing a Python tools in order to streamline some of the utilities ground movement assessment. And in particular on that one is mainly about like the reporting side of things, how we can actually link XDisp into some Python script and into generating something very quickly, and also leaving us more time to actually focus on what the engineer loves to do rather than doing lots of copy and pasting for reporting. And today, definitely what I want to focus on is actually telling you more about why the XDisp Pro is able to help us in order to link to the automation tool that my colleague actually developed. So for any urban development, and also like in particular the case study that I'm showing here, like an infrastructure project for a station design, ground movement impact assessment is really part of the design. And it's not only supporting the design, we also need it to actually understand like whether there are any mitigation required, and also actually giving us a lot more information to develop like monitoring process, as Sam was talking about as well. So the key is that like we need some tools to be able to calculate the movement and able to communicate to the stakeholder as well as the approver of the design very easily. In this particular case, it's a station design, and therefore you can imagine that like we do have lots of different construction phases. And throughout the development of the station itself, we are often asked about how we can, what are the options of facing some of the construction, and therefore being able to actually get to know and put it in one single model to actually look at a lot of different options is critical. In this particular station, on that axis is about 1 kilometers long. And you can actually see we've got like some tunnels on one side, a big box in an urban area. So there were lots of demolition before the works. There were buildings, and therefore there were small temporary trenches that we need to remove some of the obstruction. And those are the things that we are able to actually combine using quite a lot of different tools in the Oasys suite in order to link it to the XDisp in order for us to calculate the ground movement assessment. And because of the coverage of the site, the number of assets, we are talking about sometimes thousands of utilities. We've got multiple, like a lot of like underground lines in this area, as well as there are loads of buildings. You're talking about hundreds of buildings which could be impacted on the station development. So they all require assessment, and you can actually understand why some sort of automation was ultimately need to be developed in order to do the to help us out in the task. So I'm sure that this is not something that is actually foreign to a lot of engineers, which I believe is actually in the audience today, that these are the things that we are facing day in, day out as our day-to-day work. XDisp Pro is able to allow us to actually put in multiple stages, as previously Sam and Cecilia actually mentioned. So you can actually see some of the images that I pull out from the XDisp model that you can actually link with enabling works. Some of those are actually polygons of local trenches. They need to remove some of the obstruction, making way for development. And you can also import from a PDIFS model to actually look at the unloading effects. In terms of station, you can see I might have actually put in step 5 and step 6 in this image. It's just because we need to actually understand that might be areas that like the station is not, the site is not available at that particular point in time for excavation. So we just need to actually understand the effects a little bit more. And last but not least, you've got the tunneling work, which is on the eastern side of this particular site. For the station excavation, through would be one of the input data that we can put in. And in Oasys, there are some of the serial typical curves which will be available in the XDisp model, in the XDisp program itself. In the case that we are looking at here, we actually link it to more sophisticated ground movement curve derived by FE analysis, some of the third-party ones, and some of those, like in the recent days, I'm pretty sure that like we can easily link it with Gopher as well to actually get some of the ground movement to input into XDisp for the calculation itself. On the reporting side, Sam mentioned about the batch export. So an example on is given on the side over here on the right-hand side here. What is very critical for, in particular for the utility assessment, not only that like we will be summarizing some of our results on a plan so that we can actually understand in the spatial place where some of the impact might be higher and therefore need more attention. But also what is required by a lot of the stakeholder is the typical sort of like the graphs to help them out to discuss and agree in terms of what sort of mitigation or actually monitoring that needs to be required. So what Cecilia mentioned about like the details about magnitude of movement, the strain that is that is impacting on the utilities, the pull out, the sort of like all these sort of like effects. They would like to actually look at it so that for the individual, they can actually have a better understanding on what is actually required. Thinking about like if we are dealing with thousands of these utilities in particular, getting some of these into appendix of the report is not easy, and it is actually taking so much time, and it is quite a mundane task. This is where the opportunity of the automation comes in. In the key paper, there is a diagram actually showing that like the automation is actually main thing is the development of a Python script. But what I can actually flag it up here are the different XDisp function that is actually helping us to actually link it into that Python script so that the automation tool can be completed. So we talked a lot about like the middle one here, which is the XDisp model, where you can actually include quite a lot of construction stages in terms of the design. And then you can actually put in a single file. So if there are anything changes, you just need to actually do one change. Like for example, the change in diameter of a tunnel, you can just put it in one single file and it will be updated for all stages for the construction. And it can do like the ground movement calculation as well as doing the impact assessment, like what we were talking about in terms of the utilities. What is also very useful is that in the XDisp Pro, we are able to actually put the file into a JSON format. I'm not a programmer myself, but my colleague actually told me that like this particular function helped them out significantly in terms of linking to the Python script, as it is a more standard format to actually pull out the various information. And last but not least, the batch graph generation is actually a key role to actually get a lot of those standard curves in. And then it can actually go into the Python script itself with other elements of like a master Excel spreadsheet and the location where you want to actually put some of the outputs, etc., and then creates the appendix in the for the report. And in summary, basically, I think what I have mentioned here is the functions within the XDisp allow us to actually develop the automation tool. And in one of the case study, we are able to reduce a 50-hour manual job to only 10 hours. And in terms of like why there is still 10 hours, majority of the things is actually still what we need to do as an engineer is a lot of checking. Automation to only get us to one point, but it's still our job to actually make sure that what we're presenting is the right thing. And therefore that is quite a significant improvement in terms of our productivity. Also, the consistency, we will be reducing the human error, and I mentioned already about like the time and cost saving. And I think for most of our engineers, the good thing about this is we don't no longer need to actually sit there to copy and paste or actually generate the appendices for a long time. Not very interesting when you are just compiling the graphs together, but we've freed up ourselves with sufficient time to actually solve some interesting engineering problem. So that's all from me. I'll pass it to Aidan.
Thanks, Geraldine. Hi all, I'm Aidan Hopkins. I'm a senior geotechnical designer in our Toronto office. I have been with ARUP for around 13 years now and worked in various countries, typically on large infrastructure projects, typically looking at the impacts from tunneling and excavations on adjacent structures. So that's where XDisp comes in perfectly. I'm going to be essentially following on from what Geraldine talked about, looking at automating the generation of models and results. On the project I'm going to talk about, we took a slightly different approach. So there's less generation of batch graphs, but more generation of models. So what I'll talk about today is a little overview of why we did what we did and what we needed to do. how we dealt with the data management, which is key when you've got a lot of data, and how that worked with XDisp, and then the workflow itself that we've been implementing, and then what the final outcome of that is, why it's useful for us as engineers. So just the overview. So I'm working on a project with a long tunnel alignment. It's around 8 miles long, and we have multiple shafts with adit connections, so mine tunnel connections from the shaft to the tunnel alignment, which means that along that alignment, therefore, we have a lot of adjacent assets, be that buildings in varying sizes, utilities, rail lines. So we've got a lot of assets along the alignment, and our alignment is quite straight. So for those dialing in from Europe, this might look a bit odd. In Europe, our rail lines, our tunnels, when we're building them, tend to go under streets, and the streets are at funny angles to each other, and things aren't usually perpendicular. In North America, we end up with typically much more of a grid layout, and then if we start tunneling following major roads, a lot of our assets are running parallel or perpendicular, and that parallel is key to why we developed a tool to generate individual models, because we had so much data. So what we used with XDisp Pro is the COM interface, which allowed us to automate model generation, and it allowed bulk reporting, and it allowed us to work with other software to communicate results. So just to touch on why it's important that we are parallel to a lot of utilities, here's a little diagram from Lee et al. From 1992, and it's just a simple way to represent that we have a settlement trough that isn't just perpendicular to the tunnel, but also parallel to the tunnel. Now, with modern EPB machines, that pointer at the front where the settlement starts can be pushed back with controlling the pressure, but the principle still applies. We need to think about that bow wave effect when we look at our tunneling impacts. So from the data that we had for this project, we're looking at building damage calculations, utility damage calculations, and also generating settlement contours. Everyone loves that nice visual representation of how much ground settlement we're predicting. For our inputs, we had the tunnel geometries, the shaft geometries, and then those for our assets, which we either developed in-house or we generated from available information, open source data on, for example, government websites have survey data that you can use to then start generating building layouts, or utilities these days, they're getting more and more good at providing utility information in usable format. On this project, we found it less usable, and we had to start converting CAD files and adding asset information, which interestingly was one of the largest parts of the workload. In terms of other inputs, the limits of movements we were using Berland, because that's what we have in XDisp, and it works well for tunnel movements and for when we're using empirical curves. Later on in the project, when we've done further FE analysis where needed, we have looked at chording, but that's where we can then have the tilt of the structure, which feeds in better to that calc. So then also, as the others have mentioned, then the utility limits of movements, looking at strain, rotation, and pullout, depending on the asset type. Our outputs are figures, strain graphs, and I think Geraldine covered that really well in a lot of detail. And for buildings, the interaction diagrams, we only pulled those out where needed. What was more useful for us is pulling out contour plans and summaries of the utility and building damage, and those we both did as schedules and as summaries on plan, which I'll get to a little bit later. So the challenge with the model was we had a number of grids in the model for generating contours. So that you can see on the left-hand side, that's one of the grids that we spliced together over the full alignment. We have numerous utilities and numerous buildings, so thousands of buildings, thousands of utilities, and then the key point as well highlighted in the bottom on the tree there is the stages. So because of the parallel nature of the tunnel to a lot of the utilities, we're looking at the staging, not just of shaft then tunnel, but of the tunnel advance, to see how much of a length of a utility might be exceeding. If we wish the tunnel in place, the utility that's parallel to the tunnel might settle over its full length by a certain amount, and then we would be under the impression that there isn't an impact. However, it's that intermediate phase as the tunnel advances where we're most likely to be bending and generating longitudinal strains, and that would be causing impact. So we really need to look at this in more detail. Because the model was so large, trying to run all that in one go is A, very challenging on our laptops and the software, and B, very difficult for us to check. So that's where then the data management comes in. So it was quite complex. We started off with CAD information for the tunnel geometry and the utility geometry, which we then had to pull into XDisp for our assessments. We had Python that we used to compile results and modify results. And we also used FME to convert settlements to the contours that we wanted and to do some of the chainage calculations we needed to break the model up, which I'll talk about a little bit more later. We also then were outputting to the project folder and then directly to the web portal, and we did a lot of that linked through GIS. And the key thing here that's rated to XDisp Pro is that API COM interface in the center that allowed us to do all that. So we went from a large master model that was unwieldy and had all the information shown at the top to a single asset model, which had just a section of the tunnel or section of tunnel and shaft that we were interested in and the one specific utility. That way that if we were discussing utility, for example, and following up on checks, we could simply go and find that one specific file, load it, and discuss it very quickly. It loads in a second. We can make quick edits that we then back update to the master database, and allows us to really make life a lot easier and spend less time worrying about whether the file will load, less time trying to communicate clearly with others. Oh yes, you just go into the output file and you scroll through. No, we just go, there's the file, one utility, share it easily, especially with asset owners and other project stakeholders. So just to go through the workflow, we had, for example, a building database in GIS that gave us all the buildings located in plan. And then with that, we also had foundation depth information. We had information on the building type. In XDisp, we then have our building damage, and from that, we're pulling the building type, so height and foundation depth, to get our G to E ratios. And we link that through with FME to then chop out sections of the tunnel for a specific building. Python then we use to compile the section of tunnel that we need with the single building that we need, run the results, and then compile those results. The other fun thing that we did then at this stage was, rather than just running for, say, a single trough width value or a single volume loss, once we had a single file, it allowed us to iterate through multiple runs with different trough width values and different volume loss values to give a real understanding of risk. Now, when reporting the results in the end, we looked at a design value, but it gave us a profile of how many utilities would be impacted if the trough wasn't the shape that we would be expecting it to be, which will be useful in future planning. So the workflow, we start with this master model on the left, then through Python, FME, and API, we generate the single asset model where we identify the start and end changes of the building relative to the tunnel, add tunnel sections on, and then run it. Once we've got that fully run, we can then bring the results back into our building schedule. And we applied a similar workflow with utilities with the staged approach, where you can see we have the initial rings in the model, and then an interim condition, which was often critical, and then the full final tunnel installed, which was then usually the final result that wasn't critical. Doing this, it allowed us to identify where we had exceedances and then pull that out and say, okay, we had exceedances from 20 meters to 40 meters, summing up all the exceedances from the different results. So just to see that as a plot, on the bottom was the final result, and you can see here that the strains change quite a lot. So the intermediate result at the top, we're bending it in such a way that we're getting close to that limit along one length of the pipe, but then when we're fully installed, I think a station was coming in at the end of this one, the results change quite significantly. and you're seeing quite a different result. And understanding that was very important because we were looking at monitoring pipes over a certain length when we exceeded a certain percentage of their thresholds, and doing this allowed us to say, okay, monitoring of this pipe needs to start at 20 meters and end at 80 meters, rather than monitoring the whole length of the pipe even as we extend out of the zone of influence. So the final part of this was then communicating results, and Geraldine spoke about how they pulled all the results out using the batch exporter. Rather than doing that, we were looking at communicating in plan and through a web portal, because it allowed us to give access to stakeholders. They could come, they could see their utilities and see their impact in plan, how that related to other assets. So we pulled everything into GIS, and therefore you can see in plan your settlement contours combined with your building damage results, combined with your utility results, broken down by utility type, and then also in the portal you can click on it and see all the information. And all that's getting pulled from the XDisp model via the API interface and allows for easy communication with stakeholders. So that's just a little overview of how we managed a large project with a lot of data, and I think I'll hand back to Norbert for a final summary.
Thank you. Brilliant. Very interesting projects. Thank you for all four of our presenters. I see that we have received some questions. I'll have a look into those, but I actually do have a question for our presenters, which maybe I'll just tell you now. I'll ask you now, and then you can think about it while we're going through the questions. But my question was, if you had, so what reason would you give to someone who needs to assess damage assessment to use XDisp Pro? So what would be your #1 reason why you would recommend XDisp to someone who would use it on an assessment? Okay, so first question. Is there a planned upgrade of XDisp software, especially to what's related to data input and output? Example, BIM interpolability, user interface improvements, and so on. So the answer to that is we're always looking to improve. We currently are actually doing user interviews, user feedback interviews. So anyone who's interested in setting one of these up, we are just get in touch with me and I will arrange for this. As you might already know, all of our software have a user driven development. So when you talk to us and you let us know what is it that you think is needed or what could be further improved, that's basically how we keep going. So yes, definitely, if you can get in touch with myself or through the email address that I've put in the comment, that would be brilliant. Now, the next question is, utilities are at different depths. Does XDisp account for this in the analysis of excavation impact? Geraldine, you have replied to this. Would you like to elaborate a little bit on that?
Yes, no problem at all. I mean, like we've got the tunnel construction as being one of the key things, and as we probably know, the calculation would calculate anything above the tunnel access level, and therefore, if your utility is actually located in that zone, even though at varying depths along the your utility alignment, it will be captured, because one of the other key thing that we need to put in for utility assessment in the XDisp model is the location and also the level of the utility you want the ground movement to be calculated. And if it is for the excavation, so you can input ground movement curves. You can do it for surfaces, and also you can actually put in ground movement curves for various different depths, because we know that like it will vary with depth. So you can actually put into XDisp. And what XDisp would do is that it will interpolate between these curves at various different levels. And therefore, if your utility is actually within that zone, then the ground movement will be calculated accordingly.
Brilliant. Thank you. Thank you for the additional information on that. The next question, and I see someone just replied, Aidan, you just replied to that. The stage-wise modeling of the tunnel to understand the impact on the utilities involved modeling a stage for each tunnel segment, longitudinal length. So if you would like to elaborate on that.
Yeah, I think the question is looking at whether we modeled it by ring. Now, in this case, we went pretty close to what the actual PCTL ring length would be, just to capture each advance. I would say that the length is really up to you. It's not something that's determined in XDisp. So if you want to do longer sections to reduce the number of computations, that's totally appropriate. It really comes down to how you want to calculate the impact, the dimensions of your tunnel, the depth of your tunnel relative to the asset that you're looking at. So obviously, the more bits of tunnel you do, the longer the computation is, but the more detailed the results. So it's really down to you to decide things like that.
Okay, thank you. Next question is, how do you deal with discontinuities in ground movement linked to different movement profiles along a basement excavation? For example, obtained by combining output of two adjacent but different sections in 2D FE. And actually, there's a continuation to that question. How about for deep excavation? Who would like to take this one?
I don't mind, Norbert. This is one of the topics that we face in the projects that I presented, because you can see we do have varying depth in terms of excavation, and we do have FE analysis from, say, different cross-section using an FE software. There are advice in the XDisp model as to how you might want to actually treat the different levels of excavation. So there are certain advice based on papers and things like that to see like how that would be best modeled. But I share your view about when we are getting ground movement curves from different FE analysis and how that interface actually worked, because we did actually spend quite a lot of time on that when we build up our model. I think we need to, that's where the engineer needs to come in, just to see how some of these movement is able to be smooth as you go from one particular design section to the next, because we know that like ground does not discontinue on plan like that. We did put quite a lot of time to actually get a better understanding of the zone of influence for some of these excavation, and how do we need to actually put an extra ground movement set of curves in between to actually smoothen out some of those like numbers, so that like when we are looking at the for example movement along a utility, those will not cause such a big jump, saying that like, oh yeah, when you are actually crossing from one area of the excavation to the next area, then you are definitely getting some sort of like sharp change, and therefore it will show as like failure for some of those utilities. But I will definitely say that like it is not something that like a software would need to actually be so prescribed as to how it's dealing with those changes. It's more for the engineer just to see how, in an engineering perspective, how those information can be put into the tool in order to get some more representative results.
Okay, thank you.
I'll just quickly add to that, that there's also the corner stiffening for shafts that I'm sure Geraldine and Sam used for smoothing between if we're going around the corners. So where we do have discontinuous results, that can be pretty useful. and I've often used that in conjunction with 2D and 3D, with 3D to give us an idea of how that smoothing might happen, and then we can adopt XDisp when we really want to do the building and utility impact assessment to then match our corners, basically. So I just wanted to add that.
Brilliant, thank you. Thank you both. Next question is, assuming I know how to program in Python, how will I know how the XDisp code works so I can use the batch export to fill some worksheets with graphs, for instance? Do you have a tutorial? Do you assist? Can you provide help when coding? What do you recommend as the first step to use the API? Maybe I'll start off and the engineers can pop in where you want. So yes, when it comes to any of our features, we do provide full technical support to all of our clients. So if you have any questions about how a feature works or how to do any of the coding bit, we will help you out as much as we can. We do have tutorials. Cicero will be able to help out more on that topic. But I think the question for the engineers would be, how did you start? Like, how did you start your journey with the API?
So as I had said in my presentation, we do have some example files which are actually shipped with the program. So as a start off, of course, you can base your programming. You can look at how it is done. You can look at the different comp functions that are already exposed and then start off. That would be my suggestion. Of course, Aidan and the others can help.
Start simple.
Yes,
yeah,
as you should always.
Yeah, as it start simple, play around with the simple models before then pushing it out. And my programming skills are very lackluster. I often use other members of the team, but yeah, it's starting simple, as using the examples given as well, and then working from there.
Brilliant. Yeah.
Just want to add to that. I think the paper that I put on screen earlier, probably it has got a lot more details about how those Python, how does it link to XDisp and things like that. So it would be quite a good starting point as well.
Brilliant. Thank you for that, Geraldine. And I think Neve has shared that in the chat, so I do recommend having a look at that as well. So the next question, with regard to use of stages for tunnel construction to pick up intermediate cases which are more critical than the end case. How do you typically show this on ground movement contours? Is it possible to produce ground movement contours that show an aggregate worst case ground movement for each point from all stages? Similarly, oh, sorry, I just shortened that. Similarly, when you use stages, is the worst case from all stages strain, for example, for each utility presented in the results table? And there's actually an addition to this. So in particularly asking about ground movement contours with the phase 1 assessment in mind, where you might use the 1 millimeter ground movement contour to define the utilities to include in your phase 2 assessment. In that case, you would need to be sure that the contour used picks up the worst case stage for each utility.
From my perspective, so the second part of the first part of the question, if you have a stage model, the XDisp summary does give you the summary of the worst case for the stages. So it will tell you in stage 4, this was the worst case. So that's pretty straightforward, doesn't require too much effort. In regards to contours from tunneling, if you've got one tunnel, you know, the final, in terms of setting your zone of influence, the final contour, you know, that does set the area. Your utility will fall within that, but it doesn't necessarily tell you what the intermediate displacements are. So I wouldn't be too concerned about that 1 mil, given that it's additive. So at the end of the day, you do cover that whole area. I think you'd be concerned there if you were suddenly trying to model that you had intermediate grouting and then what would happen with your 1 mil contour, but let's not get into that. I think don't overthink that part of it.
Brilliant. Thank you, Aidan. Unless there are any additional comments, I'm going to move on to the next question. Aidan shows an example of a large tunneling project highlighting the project workflow. Do you mind to share these guidelines with us? That would be very appreciated. I don't know how much of what you presented can be shared as a guideline. Obviously, the recording will be available, so everything that's in there you can use. Don't know if in addition to that, there would be anything we can share.
I don't really have any guidelines, as it were. I think that's, you know, we've shown what we've done, and then I guess it's down to the engineer to see what's appropriate for your specific project.
Indeed. Okay. XDisp calculates the surface settlement and keeps the same displacements in depth as the surface settlement. But in case of utilities in depth, for example, 10 meters, the ground displacement is different than surface settlement. How this can be addressed?
I'm happy to jump on this very quickly. From a tunneling perspective,
Go for it.
Depends what curve you use, and XDisp does have the guidance there for doing subsurface displacement. So you will not be getting the same result at depth. If you tick subsurface displacement, you can pick up the curve at depth. So when you're thinking about your trough being shallower and wider at surface, XDisp will calculate that steeper, narrower one at depth if you put the right inputs in and select the right curves, and that's all covered in the help. And I think Geraldine already talked about excavations and about how you can input your excavations to give you the results at depth.
Thank you. So do we have any more questions? Oh, something just popped up. Okay, I didn't see it in the Q&A. Well, just in case if something else comes up, we do have 1 more minute left, and I did want to ask, in light of the work you have presented, what would be the one reason you would give someone who needs to do a damage assessment to use XDisp Pro? And any takers first? Sam, go for it.
The stages. I think that's a massive benefit of XDisp Pro. It's so crucial for a lot of the questions that have come up in the Q&A. The staging is really useful.
Aidan, Geraldine, any different opinions?
I think in terms of like what is already included in the XDisp, is already included a lot of the different assessment method in the sense of the key ones that we are normally like use it day in, day out in terms of the burden assessment as well as the utilities assessment. It has come a long way because I think about only 10 years ago, utilities assessment are probably been done using Excel spreadsheet. So knowing that like the standardized method actually puts into the XDisp program itself, it's actually quite useful. And I know that like there have been lots of like testing and things like that like going on in the background. So it's just like giving us the confidence that when we are doing like some of these impact assessment, yes, if we're dealing with utilities, a lot of those, then definitely would be the program to be used.
Ben, thank you. Aidan, any comments from you?
Yeah, it's in the comment about, you know, I think it was part of the improvements to XDisp and linking to BIM. And I think even already, as I think we've shown with the API and COM interface with Pro, you can really link it in as part of your project workflows. And that's really key if you're working on major projects.
Brilliant. Well, with that, thank you all for all your questions. I know there are a few which we haven't managed to answer, but we're going to get back to you in an email for those ones. Thank you for all of our presenters. Brilliant presentations, case studies. And with that, I'm going to thank all our or participants and anyone who joined us. If you have any questions about any of our software, you can reach out to us at oasys@arup.com. And just stay tuned because we are going to have more webinars in the coming months. So make sure that you follow us on LinkedIn so you're up to date with these. And with that, I'll thank you everyone for being here and see you soon.